That's it. That's my recap. No, there was like 33 talks. I couldn't attend all of them, of course. So I tried to digest, which is a joke that will make sense in the next minute or so. I tried to digest everything in the past 30 minutes, but of course I was not able to do that quite aptly. So I was kind of obsessed with this analogy of ecosystem, and it evolved into this analogy of improving the efficiency of our geospatial metabolism, and how all of our talks in track 2, Cloud Native Geospatial in Practice, all of our talks were basically about improving the efficiency of the system, or how we're using those tools to create cloud native applications. So first of all, we're starting with how do we find the right data set? How do we find the right data fast? So we need high quality metadata that is AI ready, and we are challenged by things like how Stack is implemented differently, and this is like the federated search problem. So I know, and this was in one of the presentations, but basically how when you want to search across Stack catalogs, it's like impossible to do that in a uniform way. You basically need to create special adapters. We got introduced to the idea of data candor and how a framework like data candor could help us create better metadata through AI and also for the use through AI. And then there's a lot of really cool new methods for indexing. So that includes both different types of spatial indexes, as well as these actual indexing systems, or I'd say query engines, I guess, such as Iceberg, Iceberg and Sedona, and then like the formats that also leverage them, like GeoParquet and GeoArrow. And so then we need to metabolize that data efficiently to create more evolved data, which is just another word for insights. There's this useful breakdown provided by Tom Augsburger of I/O or compute being a bottleneck. And so if I/O is a bottleneck, we can basically throw more distributed computing at it. So that's like using Dask infused. We can also reduce I/O by using some of these cloud-optimized geospatial formats and spatial indexing. And if compute is a bottleneck, maybe we can even use the GPU. So I apologize in advance because this is definitely not representing all of the ideas that were presented, but what I could cobble together. Some other takeaways was GeoArrow was used in the first two presentations, one for front and back end. This is a pretty cool use of the utility of building Rust libraries and then binding to other languages. And I want to thank Sean Harkins, Julia Signell, and Pete Godomsky for helping me with some of these takeaways since I wasn't in the room at the time. We need good ZAR and GeoParquet visualization and tooling, and benchmarking is hard. And the big news is that we solved ZAR versus COG. I'm not going to explain it right now, but maybe we should write a blog post about it. And then this is leading into my what should we keep thinking about, which is that we can keep making things more efficient, but no one will ever eat. So we have this example, we had this really great example of Floodbase and how they're still using, or they're leveraging COGS really because they're still very mature and a lot of their users depend on COGS, and you can just drop COGS into QGIS and have it work. So with that, I'll close my summary of track 2 with just this question of how do we balance building more and more efficient tools with getting people to use the tools that already exist. Thanks.